Hey class, I just wanted to go over confidence intervals in a slightly different way based on your questions and responses in the homework. So, suppose, well, you'd like to know, for example, the true average commute time for a certain city. Um, in practice, I'd go and ask as many people as I want and compute an average, and based on that, I'd get some point estimate. But for confidence intervals, especially bootstrapping confidence intervals, we're going to do something a little bit different. Imagine I get 400 people, 400 different researchers together, and each of us goes and asks the same number of people, say 100 people, what their commute time is. So I would go find 100 people, I'd ask those 100 people their commute times. Another researcher would go around, ask 100 people, maybe some of the same people, maybe different, get all their commute times, and each of us gets our own little data set. From my data set, I compute a sample mean time, and from every single person who does this, each of us gets their own sample mean, and we put all those values in order. Whoever got the lowest sample mean is at the bottom, whoever got the biggest sample mean is at the top. So each of us, all 400 of us, have a different estimate at what the true commute time is. Now, since we have a large variety of values, in all likelihood, the biggest value and the smallest value are incorrect. And so to generate a 95% confidence interval, I'm actually going to take the 2.5% of the biggest values and 2.5% of the smallest values. So out of the 400 values, I'm kind of getting for a 95% confidence interval, I'm getting the middle 95% of the values. That ends up meaning I'm going to take the 10 largest values and the 10 smallest values and cut them off. So this is the list that remains. X11, since I cut off 1 through 10, and all the way up to X490, the largest value in the middle 95%. And so these extremes give us our confidence interval. So in short, everyone gets their own estimate, and we cut off the bottom, the smallest values, and the tallest values, and are just looking at the middle. We can't actually do this in real life, of course, but we simulate it through bootstrapping. And that, in short, is at least one explanation, one interpretation of how a confidence interval is generated. You look at all the possible values, and you cut off a certain amount off the top and bottom based on what level of confidence you're looking for. The other question I had is about misinterpretations. Again, these are the misinterpretations on page 187. I had a homework assignment related to that. Misinterpretation 1. A 95% confidence interval contains 95% of the data in the population. This isn't quite right because we're not talking about where the data is. We're talking about a parameter of interest. I'm 95% sure the true mean is at a certain place. I'm not asking where individual observations are. I'm asking where's the mean. So I don't really care where 95% of the data is. I just care about where the mean, the true mean could be. Misinterpretation 2, I'm 95% sure the mean of the sample will fall within 95% confidence interval for the mean. Again, we're not talking about we're looking for the true mean. We have the sample mean, but we're really looking for the true mean. I'm 95% sure about the true mean. I'm not 95% sure the sample mean's in the interval. I use the sample mean to generate my interval, so of course it's going to be in there. Error. Misinterpretation 3, the probability that the population parameter is in a particular 95% confidence interval is 95%. This is false because a parameter is the truth. It's either true or it's not. There's not a probability that it's true or not. There's a probability that we are correct or incorrect. So we are the ones who have the confidence issue. The truth doesn't have a confidence issue. So there it is. Please feel free to ask questions, and I will talk to you later.